Good morning, students. Today let us learn refraction of light. When light passes from one medium to another, it bends towards the normal, or the path of the light changes. The angle between the incident ray and the normal is called angle of incidence, I, and the angle between refracted ray and the normal is called angle of refraction, R. If the first medium is optically rarer and the second medium is a denser medium, angle of incidence will be greater than angle of refraction. Let us see the second case. Light passes from denser medium to rarer medium. Then the light bends away from the normal. Our angle of refraction is greater than angle of incidence. In the third case, the light gets incident normally on the surface. Here angle of incidence is 0, angle of refraction is also 0. That is no change in the path of the light when light gets incident normally on a surface. The change in the path of the light when it enters from one medium to another is called a refraction of light. According to the laws of refraction, the incident ray, the refracted ray, and the normal lie in the same plane. And the second law of refraction is known as Snell's law of refraction. According to Snell's law, sin I by sin R is equal to a constant, and that constant is denoted by n21. It is a refractive index of second medium with respect to the first medium. n21, that is the relative refractive index, or it is the ratio of refractive index of second medium to the refractive index of first medium. We have already learned in 10th standard that is the refractive index of a medium is the ratio of speed of light in air or vacuum to the speed of light in a medium. Refractive index is a measure of optical density. As refractive index increases, optical density increases, or the speed of light decreases. That is the cause of refraction. When light enters a medium, the speed changes. Now let us see total internal reflection. Let us consider an object in the denser medium. O is the object in the denser medium with a refractive index n2, and the light from the object passes from denser to rarer medium. Consider the first ray. Here the ray bends away from the normal. If the I value is increased, then R value also increases. Let us consider the second case in which I value is increased such that the R value is maximum. The maximum value of R is 90 degree. The corresponding angle of incidence is known as critical angle IC. Consider the third case in which the angle of incidence is increased beyond the critical angle. The ray gets reflected. This phenomenon is known as total internal reflection. So the two conditions for total internal reflection are the light should pass from denser to rarer medium, and the angle of incidence should be greater than critical angle. Let us apply Snell's law. in total internal reflection. That is, when I equals IC, R is equal to 90 degree or pi by 2. According to Snell's law, sin I by sin R is equal to refractive index of second medium, that is N1, with respect to first medium, that is N2, because the light passes from N2 to N. So sin I by sin R is equal to N12, that is equal to N1 by N2. When I equals IC, R equals 90 degree, so sin IC by sin 90 or pi by 2 is equal to N1 by N2. As sin pi by 2 is 1, we can say sin IC is equal to N1 by N2. Or let's take the reciprocal. N2 by N1 is equal to 1 by sin IC, or 1 by sin IC is equal to N21. Refractive index of denser medium with respect to rarer medium.